In this video, we'll talk about Hamilton's apportionment method. And in order to do that, we need to know how to find the standard divisor, which is total population divided by number of items allocated. And we need to know standard quota, which is the population of a particular group divided by standard divisor. So let's say we have this specific example. We have 5 hospitals and we want to apportion 150 doctors. And as you can see, I didn't say divide 150 doctors because I do not want to divide them evenly and say 30 doctors for each hospital. And the reason is, if we look in the table, the average weekly patient load is different for each hospital. So it would not be fair to have the same amount of doctors for a patient load of 1,827 like it is in hospital A, and the same amount for 6,470 patients, which is in hospital E. But anyway, let's start by calculating the total. So the total number of patients in all the hospitals is adding all up. So we have to add up this column, add all of them up, and end up with 21,000. So we have 21,000 patients in total. So, knowing this information, we can start by calculating the standard divisor, which is the total population, 21,000 patients, divided by 150, because that's what we want to allocate, 150 doctors, and we end up with the standard divisor being 140. So let's calculate the standard quota for each of these hospitals. So the way we calculate the standard quota, we do 1,827 divided by the standard divisor. So 1,827 divided by 140, and we get 13.05. And then I divided all the other average weekly patient load for each hospital by that standard divisor, and I wrote the answer using 2 decimals. So I did 22.66, and the hospital C, the standard quota, has 30.04. 5,325 divided by 140 is 30.04, and 6,470 divided by 140 is 46.21. But we cannot use this in real life, right? Because we cannot distribute 22.66 doctors, right? So then we are going to use Hamilton's method. But before I get to the actual method, I am going to expand this table and write lower quota and upper quota. What that means is I'm going to put the whole numbers that contain each of the decimals that I got in standard quota. So 13.05, it's between 13 and 14. So the lower quota is 13 and upper quota is 14. In other words, I rounded down 13.05 and then I rounded it up. And then 22.66 is between 22 and 23. 30.04 is between 30 and 31. 38.04 is between 38 and 39. 46.21 is between 46 and 47. So we found the lower quota and upper quota. And let's talk about Hamilton's method. Well, Hamilton's method deals with lower quota. So I'm not going to deal with upper quotas at all. I'm just going to look at lower quotas. So 13, 22, 30, 38, and 46. If we add all these numbers up, we actually get 149. So we got one extra doctor that we need to assign somewhere, right? We had 150 doctors in total, and when we added the lower quotas, we got 149. So we have to assign one doctor to one of the hospitals, right? Because each of these lower quotas are the number of doctors that you have to apportion to each of the hospitals. So I want to put one somewhere. Well, Hamilton's method says add the surplus of doctors to the values that had the highest decimal parts. So I'm looking at my standard quotas and I have 05, 0.66, 04, 04, and 21. So the highest decimal part is 0.66, the next one is 0.21, the next one is 0.05, and then the other ones are 0.04. So the highest one is this one for hospital B, which means to our lower quota of 22, we are going to add one more doctor. So Hamilton says this was going to be 22 plus 1, 23 doctors are going to go to hospital B, and the other values stay the same. 13 is 13, 30 is 30, 38, and 46. So now if we add up all these doctors, we are actually going to end up with 150 doctors, which we had originally. If we had a surplus of 2 doctors, for example, we would have added 1 to this value first, and then we would add another doctor to this one, to the 46 doctors. We would add one more and we make it 47 doctors. I hope this helps.